So what do you know about Golang?
I want to start from zero. I don't know anything.
What do you know about? There is another guy joined. His name is Sai. Okay, what do you know about Golang actually? You know, there are multiple programming languages and all, right? So
Yeah.
there is Java, there is C++, and then there is other Python, JavaScript, or Node.js. All these programming languages are there. What makes Go a unique, and then why people prefer nowadays? Many companies they prefer to use Golang for their backend development or server development. First thing, it's a compiled programming language.
Mm-hmm.
Compiled programming language means unlike Python, Python has got an interpreter, but Golang is a compiled programming language. That means there is a compiler. Once you write your code, you have to compile it. Once it is compiled, then it gets compiled to uh, plan line assembly, and then there is an assembler. That assembler will convert to machine code, and then there is a linker that links everything, and then it generates a binary. If you are creating a binary means an exe file or binary or same executable. You can think it as an executable or binary file, and it's a general purpose programming language. It's general purpose programming language means you can use it for client side development, you can use it for server side development, you can write CLIs, you can write provided by the tools and libraries, you can write GUI based applications, you can write websites, you can write command line based applications. It's a general purpose programming language. Okay, that's for general purpose. And some people call it as it's a systems programming language. Systems programming, the word systems is pretty subjective. Definitely, you cannot create a operating system that gets boot up from the boot drives. You cannot create an operating system like that, but you can create a system that can manage its own resources. Let's say you can create a server, you can create a database, you can create a system that can have multiple workers. Okay. System is very, very subjective here. The word systems programming language, it can manage its resources. Its resources means with respect to the system, but not actually the operating system resources. Sorry, that is a different thing. Writing an operating system, writing a system from the scratch, or creating an operating system that can be boot up from the scratch. Okay, that's a different thing. There is a separate system programming languages out there, C, C++, Rust, etc. But Go is not systems programming language with respect to that. You cannot write a firmware, but there are some other projects going on, which is called TinyGo. It runs on LLVM. So there you can, at least for Cortex and some processors, you can write. But still, they call it as systems programming language. Fast compilation. Go has fast compilation. Go compiles applications very fast. Compilation is a process. Once you write your code, then there is a compiler for for all compiled programming languages. That compiler compiles your code. Compiles your code means it verifies. There is a process for that. There is something called tokenization. There is a lexical syntax, and then it performs a abstract syntax tree. Okay, and then it gets compiled. It verifies that whether the code is a legitimate code or not. It verifies the code whether the code that is written is correct code or not. It does certain things. It does certain things which we call it as a compiler. But The features of Golang is Go does fast compilation. That's one of the important features of Golang. Go does fast compilation. Fast compilation means I think I still remember when I was working with on a Java project long back, maybe more than 10 years ago. I used to write program and then I compile it. Uh, okay, I go have some tea and come back. It used to take 15-20 minutes for compilation itself. Because maybe system resources are not as powerful as it is supposed to be. At the same time, programming language itself is the compiler itself is pretty slow. It may be pre-processing step. It was very slow to compile your application. Even the applications are very big. That was fundamentally one of the biggest problems with compiled programming languages. Compilation time should be very fast. That was one of the pain point that Google faced, and then one of the requirements of Go programming language is it has to be compiled very fast. Go compilation speed is really blazingly fast. You cannot compare Go with any other programming language with respect to compilation speed. Even today, if you would like to compile your Spring Boot or Java application, it takes at least 15 to 20 seconds or 30 seconds of time. Okay. But Go compilation is very fast. There are various reasons for that. It has there is no pre-processor kind of a thing. There are no macros in Go, macros in C language, or macros in Rust, macros in C or C++. Macros, what they do, they generate some code during compilation. There is a pre-processing step. So there are no macros, and Go does not compile. For example, you are using a lot of packages in Go. Though Go does not compile each and every package again and again. Go compiler is very intelligent that whatever gets changed, whichever the package that got changed, only that gets compiled. First time compilation, it may take little time, but next onwards, it is very clear about what got changed in the project. Based on that, for example, there are 5-10 packages. 5 packages are there in the project. Package 1, 2, 3, 4, and then only package 5 got changed. It doesn't compile and then it doesn't create object files of package 1, 2, 3, 4. Only 5 got changed, so it recompiles only package 5. So Go compiler is pretty intelligent and then it does fast compilations. One of the compelling feature of Go is fast compilation. Minimum language, easy to learn. Go language is very easy to learn. The reason is from the inception to today, there are only 25 keywords in Go. I don't know any other programming language you can say that how many keywords were there in Java first version, Java second version, and Java current version 1.23 or 1. Even the Rust, even C++. Many keywords got added, many keywords got reserved, some of them are removed. So we cannot roughly maybe 50 plus keywords are there, but we cannot say. But Go is the language that was developed very clearly that the first version of Go till the current version of Go, there are only 25 keywords in Go, neither added nor removed. There were no reserved keywords as well. There are only 25 keywords. Pretty clear about the keywords in Go, 25 keywords. But how if the keywords are less, how the language is easy? Keywords are less, so while you are working, because each and every keyword has its role to play in Go language. There are some keywords which are very rarely used in other like volatile is a keyword that we rarely used in I think Java or C sharp. There are few keywords. Extern, there are few keywords that we rarely use. But Go keywords are almost in 25 except one or two, maybe fall through or something. We regularly use all these 25 keywords. Maybe fall through we don't use that regularly, but we regularly use all these keywords. So the programming language is pretty concise. It sits between You know, C++ and Python. C++ is, with respect to performance, the C++ is one of the best high performant programming language. When you look at the Python, it's very easy to write. It's like a simple English you are writing. Go sits in between. It is pretty good performer in terms of performance. It performs very well, and it has ease of writing application, right, ease of writing programming like Python. It's not like Python. Python philosophy is different. Python way of writing code is different, but it is easy to write Go applications. So I'm not just comparing with Python only to say that it's easy to learn and easy to write. I'm not comparing Python syntax. Python syntax is different, Go syntax is different. Go follows the C language family of syntax. C language, C family syntax, easy to learn. Go has got a garbage collector. You know, when you look at memory, variables are created. When you create a variable and assign a value, variables are created in different segments of the memory: code segment, data segment, stack memory, and heap memory. Generally, there is no problem with code, data, and stack, but there is a problem with heap memory. The problem is heap memory is a growable memory. You can grow the memory when your application is running. So, either as a programmer, you should know that how much memory you allocated, so that you need to deallocate manually, like in C, C++, or there should be some separate program or an application that is running behind the scene that keeps on running, and then it has to uh, deallocate the memory automatically. Garbage collection is one of the features. Like Python has got garbage collection, Java has, C Sharp has, uh, NPM has. Like many programming languages, they have garbage collectors. Garbage collector is one of the best features for application programming, not for low level system programming, application programming. Go has a garbage collector. It's a concurrent garbage collector and low latency garbage collector. Low latency and high throughput garbage collector. Low latency and high throughput. Why latency is very important for garbage collection generally? When you are running your application, when your application is being run, when your application is run, there is an algorithm called stop the world. Generally, garbage collectors follow that algorithm, which is called stop the world. What that algorithm does is it stops the entire application, whichever is running. It stops the application. It pauses for a while, maybe in milliseconds. For every few milliseconds, it stops the application for a few milliseconds, and then it clears. It deallocates memory, whatever the memory that is supposed to be deallocated. Okay, heap memory is it gets allocated, and then heap memory has to be deallocated. Then only the memory, anything, if an application is running, it doesn't have abundant memory, it has some memory. Okay, system cannot dispense the whole memory that a system has got to your application. No, it gives sufficient amount of memory. Your application should efficiently use that memory. How can it efficiently use the memory? If there is a garbage collector or manual memory deallocation. You allocate some memory and you deallocate the memory, whatever is allocated, when there is no use of it. That is done by garbage collector. Low latency means the garbage collector passes are comparatively less, and then the pause is not for longer time. One of the biggest problems with Java or C Sharp as well, the pauses are throughput is very good, but pauses are longer than actually what it is supposed to be. They might have fine tuned it still. What is the meaning of pauses are for every, for example, I'm telling you like an example, for every 10 millisecond, there is a pause for 5 millisecond. Okay. An application that is something like lot of data is coming to your application, hitting your application. That is very costly thing. That application has to pass for 5 millisecond. Within that 5 millisecond, lot of data that hit your server, which has to be processed. So the pauses should be minimized. So Go's garbage collector is fine tuned to have smaller pauses with uh, lesser time. So what happened? The latency is very low. The latency should be low and throughput should be very high. Java is fantastic for high throughputs, but Java is not that great for low latency. Overall, yes, it is very good. It's Java garbage collector or JVM itself is very time tested and very good. But when you compare with Go and Java, Go is designed for low latency, Java is designed for high throughput. It doesn't mean that Go doesn't have so much of latency, comparatively high latency, but overall it is good. When you compare with Python or when you compare with NPM and all, Java's latency is pretty small, low latency. It's time tested. Still, that is the reason banks and all they don't want to go away from Java. Okay. If you want to run Python on your machine, what is required? I'm asking you a question. For example, I have a Python application. Okay, you have to run Python application on your machine. What is required? I think if you're speaking on mute.
So nothing. We have to uh, check that Python version is compatible.
That means on your machine, Python has to be Python virtual environment or something has to be installed.
Yeah.
If you want to run Java application, JVM should be installed. If you want to run .NET application, .NET runtime has to be installed. Again, NPM application, NPM has to be installed. Similarly for Ruby on Rails, all these applications. That means you need to separately install the runtime. Okay, installing a runtime is sometimes it requires more resources. Approximately 100 MB, 50 to 100 MB is required just for Java virtual machine. Maybe similar for Python as well. So you need to install a separate runtime in order to run your Java applications. A separate runtime, of course, C++, Rust and all, you don't need any runtime. But Java and other programming languages with the garbage collectors, you need to have a separate runtime. In Go, no need to install runtime. You don't need to install any runtime. Go creates static binaries. Static binaries means you don't need to you don't need to install a runtime. If you cross compile your Go application, for example, I am on Windows machine and then I cross compile my Go application for Mac, then you set up the target and then you cross compile your application. You don't need to separately install anything on the target machine. You just drop the binary. So the binary contains a minimalistic runtime along with it. A runtime is packed along with the binary or executable, whatever you call. The runtime is packed along with the binary or executable. So the size is maybe 2 MB, 3 MB, something like that. It doesn't go more than 10 MB maximum. But for Java and all, two problems here. Number one, it has to you have to install a separate runtime, JVM. So JVM does the just-in-time compilation, which takes some time to start the application. Few seconds it takes, and JVM itself is 50 to 100 MB, and then your application may be your bytecode or something could be few KBs to MB. Then the whole application comes around 100 MB. If you want to run one application, if you want to run multiple applications, yeah, the same JVM can be used. That's a different story, but generally. So what happened? There is a burden, there is an additional installation, there is an additional application that has to run. Other than your Java application, the JVM has to run. JVM requires a lot of resources. At least half a GB of RAM it requires, at least, or 256 MB of RAM is required just to run JVM. Forget about your application. But the current trend of cloud native computing, if you look at cloud native computing applications that are poised to run on cloud as containers, they should be pretty fast. They should be pretty fast actually. They have to spin up within seconds actually. They have to be scaled up or scaled down within seconds. When they can spin up in seconds, when they can be scaled up or scaled down in seconds, when the dependencies are fewer dependencies, then it is easy to spin up. No separate runtime has to be installed. Then what happened? It takes less time. Even to start the application, it takes comparatively less time than Java. Startup times of your application are very minimal. Don't compare with C, C++ or Rust. You compare because it's a garbage collector. You have to compare with Java, C Sharp or Python. Even the performance also you need to compare with Java, C Sharp or Python. You cannot compare the performance with C, C++ or Rust. That is not possible with a garbage collector. So that's cloud native, designed for cloud native computing. Designed for cloud native application development and deployment. So applications that are poised to run on cloud or should be blazingly fast, should be small in size. Okay. Let's say that I want to run a Java application, Java web service. You need to have either Tomcat or Jetty. Jetty also recent innovation. Recent means maybe 5 6 years or 7 8 years. Tomcat was the server. That means you need to install a separate server, web server called Tomcat. But Go applications are self-hosted. Python also has them. These applications are self-hosted. So you don't need to write any separate, you don't need any separate container to run your web applications. HTTP package in Go itself is it acts as a container. It starts listening to all the requests that are coming to that particular route on a particular port. You don't need to separately write a server. You don't need to separately install a web server and then configure your application on server. So this is also one of the features for cloud native application development and deployment. Cloud native applications that are native to cloud are pretty fast, agile, and their startup times are very minimal. They run very fast. That's what cloud native application development and deployment. Cross compilation, cross compilation and cross build. Okay, you can say cause. On which are the operating system or the architecture that 86, 8086, I mean 386 or 64 bit ARM or MIPS or S390, like IBM's mainframe just 390. You can be on any machine, and then you can cross compile to a targeted architecture. That means you are writing your application on MacBook, but the executable should, it has to create a, it has to build and create, it has to build an executable for Windows. Or you are on Windows, you can do it for Linux. You can do it for Android. You can do it for Mac OS or iOS. Whether they run on iOS or not due to other constraints is a different thing. Still, you can cross compile your applications to various operating systems. Cross compilation is one of the uh, wonderful features of Go. Now, many programming languages are coming with Rust also has cross compilation, but the cross compilation of Go is very easy. There are dozens of, even you can write WebAssembly. You can compile to WebAssembly. WASM, you can compile to WASM. WebAssembly is a a growing technology. There is a target of cross compilation target called WebAssembly. Okay, cross compilation and build process. Go has that, one of the wonderful features. And Go concurrency. This is one of the major features people like Go language. Go concurrency. Go language concurrency follows something called CSP, which we call it as communicating sequential processes, which we call it as CSP. Go follows something called CSP, communicating sequential process. It is written by Tony Hare, a paper that was written in, I think, 1970s, early 80s or late 70s. He wrote a mathematical white paper that how multiple processes can run and can communicate concurrently. What we are talking about, communication between multi-threaded applications or communication like async await applications nowadays in Go language as Go routines. It is influenced by CSP paper. Go concurrency is very famous. Uh, One of the very famous concurrence, asynchronous programming, concurrency, Go routines, Go channels is one of the wonderful features of Go language. Go concurrency. Go has concurrency is a first class citizen in Go. It's very easy to write concurrent applications in Go. With a keyword you can write concurrent applications. Distinct exception handling. Error handling or exception handling in Go is quite different, unlike other programming languages. Generally C++ family languages, like we put try catch block, even in Python, try catch block. There is a try and then catch. It looks for exceptions in the try block. If there is any exception is caught, then it goes to catch block. But Go took a separate route. Errors are considered as values in Go. There is an error. There are two kinds of errors. Maybe runtime errors, errors that are created by user defined errors, runtime errors. Errors are created by the system. There could be fatals, that means application cannot recover from the error. There are panics. So let's say that you are trying to connect to a database, but the database connection is lost. It tries for some time, and then if your application is not connected to the database, there is no point even in running your application, because database connection is the very it has a paramount importance for an application, because all the data has to be inserted into database or transferred to the database or fetched from the database, read from the database. If the database connection itself is not established, then we can call it as a could be a panic. It could be some exception in the system that it's a panic. It could be a fatal as well. That means if the database connection is not established, there is no point in running the application. So I'm just exiting the application, whatever. Go has got a separate exception handling technique. Exceptions, errors. Errors are values. We call it as errors. Errors are values. Okay. You have to give a message when there is an error, and you need to check properly each and every case of the error. Whatever the code that you are writing, you need to check whether that code leads to an error or not. If there is an error, return an error or raise a panic. We will discuss about it, panic and all the things. So what happened? You have granular control on your code, because you blindly don't go and put a try catch block. You know where your application may there where it may occur some errors, where errors may be erased. Based on that, whenever you are writing code, you clearly that okay, there is a chance that there could be an error. So if so and so, then return an error, or so and so, make it as a panic, something like that. So because of this particular feature, there is a granular control for the developer programmer on his code. Okay, variables are statically typed. This is very important. Statically typed is uh, akin to Python. Python is a dynamically typed. Statically typed means during compilation itself, what is the type of a variable, what kind of values that the variable is going to store, how much memory is required. All these things should be noted to the. All these things are aware to the should be aware to the compiler before going to run the application. During compilation itself, the type of a variable has to be defined properly. If the type is defined, automatically the size is also evaluated. If it is an integer, what is the size? If it is a float, 32, what is the size? If it is a string, then what is the size? So Go promotes statically typed. Go type system is a statically typed type system. No inheritance. It's not object oriented. Not object oriented. I can say, according to me, I feel it is a hybrid. Not object oriented, not only procedural. Can be hybrid. Can be called as hybrid. Object orientation is a separate thought process. You need to consider everything as a, you have to classify everything, and then you need to create an objects for your classification. The entire application is like that. Java is 100%, Java, C Sharp and all 100% object oriented. C++, you can write object orientation. At the same time, you can also write procedural code. You can just write functions and then execute them without even classes. C language, there are no, it's not a object oriented. You can write functions. But Go, it is not object oriented, but everything that you want to achieve through object oriented, you can achieve through Go, but in a Go way of doing things. Go has got its own idiomatic approach. In the Go way of doing things, you can create objects. Of course, you can create objects. You can create types like structs. You can create user defined types from the existing type or from the struct, whatever you can create. But they are not object oriented. That means there is no hierarchy that a object is derived from, a class is derived from other class. There is a base class. There are virtual functions. There is a override, overrides. All these things are not there in Go. You can do object oriented way of doing things, but in a separate Go idiomatic approach. Go has got an approach. Through that approach, you can achieve everything. What happened? It simplifies your application development basically. Go has got a package system, right? It simplifies. Go uses static linking. Static linking and static binaries. Linking is a process. There is a linker. Okay, when in the compilation process and build process, if you look at a build process, the last step of build process is a linking. Usually there is a linker in each and every operating system, LD or something. There is a linker. What that linker does is just your code does not run on an operating system. If your application, it has to be created as a binary, other than your code, it requires some system libraries. It requires some dependencies. Along with those dependencies, only your application can run. If a binary is created, along with that only a binary can run. This we call it as a linking process. Static linking means whatever the binaries that are required, whatever the dependencies that has to be linked, they are statically linked along with your binary. It may increase the size of your binary or executable. Binary and executable are same. Windows systems we call it as executable. In Unix based systems we call them as binaries. It may slightly increase the size of your binary, but it eradicates the dependencies. Dynamic link means once your binary started running or your bytecode started running on JVM or your Python application started running, it looks for different binaries. It looks for different dependencies. You want to perform file IO operation. That means you want to open a file, write to a file and close a file. There are some system libraries with respect to file operations. You want to perform a network operation, a socket has to be opened, data has to be transferred through the socket, okay, or a port has to be listened or send some data to a port through HTTP or TCP or any other through any other protocol. It is called a network operation, network IO operation. It requires separate dependencies from your operating system. So static linking is a feature that all these dependencies are bundled together along with your binary based on the operating target operating system. What is the benefit of that is? The benefit is once the binary is there on your machine, on the target machine, it start running, the startup times are comparatively less. It starts very fast. And then it doesn't look for the dependencies. It doesn't look for the shared libraries or any other dependencies because all the required dependencies are already there inside your binary. Of course, it's a process. It has to search somewhere. No need to search anywhere. Those are all bundled together along with your binary. So static linking is uh, one of the compelling features. I really like this feature. If you look at latest programming language, something called Zig, it also performs the static linking. Static linking is wonderful features. It's a very, very good feature. Static linking, libc, glibc, musel, all these libraries are there inside your system, and then those libraries has to be linked. Without that, just with your code, with the code that we write, it doesn't run on an operating system. It requires some dependencies with respect to the operating system. Those we call it as static linking. So when you compile your application and build a binary or executable, the dependencies are statically linked along with your binary, which we call it as a static link. Statically linked. Okay. So just have these are the features. Any questions you have?
No, Jay.
Yeah, cool. Now coming to the compilation process. I would like to simplify this. I don't want to take, I think today we can complete until the compilation process. Generally what you do, you write Golang code, Go source code. When you write Go source code, there is a Go compiler. The compiler performs some compilation steps. So as I said that it converts the code into tokens, there is a lexical syntax, and then everything is converted as AST, abstract syntax tree, and then it verifies whether the code is a legitimate code or not. So this is your source code, this is your compiler. Then the compiler tells that whether the code is a correct code or not, first of all. If there are any errors, compiler catches those errors and then it gives the information that hey, something goes wrong, correct your code, something like that. Once it is compiled, it writes some intermediate code, that is called plan 9 assembly code. Why plan 9 assembly code? It's a textual processing actually from your source code to this code. That means this code is converted on a successful compilation. This code is converted to this code. That is what it happens. For example, for C language and all, there is a GCC compiler or Clang compiler, LLVM compiler. It converts into IR representation. Java, it converts to Java bytecode after compilation. C sharp convert to intermediate language. I think it was Microsoft intermediate language. Now, since it is an open source, they are saying that just IL intermediate language. Compilation process is pretty big. Okay, it's a very intricate process. It's not easy to write a compiler, particularly for a language something called Go. Where this Plan 9 came into the picture? Plan 9 is an operating system created by the same inventors of Go. If you look at Go language, Go started in 2007 in Google by Rob Pike and Ken Thompson. spelling mistake, and Robert Grisimer. These are the three guys who started Go language in 2007 and released open source it in 2009. I started using Go from 2012 onwards. 2009 they open sourced it, as far as I remember. The same guy, Rob Pike, if you look at Rob Pike, his meetings and all, he wears very glazing brushes, and then you can because of his dressing, actually, he's a bald-headed guy, and then you can easily uh, give attention to him. Very wonderful speaker, not because of his dressing, but because of his knowledge. But he can easily get the attention because of his dressing. Rob Pike, Ken Thompson, and Robert Grisimer. These guys has created Go language. Rob Pike and Ken Thompson also worked on an operating system called Plan 9. I think Plan 9 was a first network based operating system. I think first network based operating system, which was very, very successful in terms of innovation. Maybe I don't know the purpose of that. It was not commercially successful, or they did not intend to really make it as a commercially success. But from the uh, research point of view and innovation point of view, Plan 9 is a wonderful operating system. Both Rob Pike and Ken Thompson did work on Plan 9. I think they also worked on C uh, and Unix as well. They created some assembly code, which we call it as Plan 9 assembly code. This is the IR representation, intermediate language representation. That means your Go source code is represented as Plan 9. Let's say that I created my own operate programming language. For example, JP. I write a code source code in my JP. I create a JP compiler. This compiler converts the code to Plan 9, for example. So, as a creator of a programming language, my focus is specify the language, programming language specification, and then write a compiler. The compiler converts everything to Plan 9 assembly code, which is a intermediate. This is a hypothetical fictitious programming language. There is no programming language called JP. I am just telling you. Once you write to Plan 9 assembly code, then what is the next step? Assembly code is written, and then there is a component called assembler. It takes the assembly code, and there is a component called assembler. This is also Plan 9 assembler. This assembler converts this code into machine code, and there is a linker. What the linker does, it takes this machine code dot, I think, o files, I guess. A linker links other dependencies, and ultimately bundle everything as a binary. So if I create my programming language, I just need to convert it to Plan 9 assembly code, which is a assembly language. It's a virtual assembly language. This assembly language is not for any architecture. It's not for ARM. It's not for 86 AMD processors. It is an assembly language which is like an intermediate representation. But there is an assembler. That assembler converts everything to machine code, and then there is a linker which links and everything. With this object files, it links some other files and it creates a binary. This is the process. That means if I create a programming language, I just need to write a compiler. That compiler should convert to this. Similarly, if you look at Java, sorry, if you look at Java source code, and then you got Java compiler. This compiles everything to Java bytecode. From here onwards, the JVM takes care. JVM and then JIT compilation will take care. Similarly, if you look at it, there is a programming language, something called Kotlin. Similarly, there is a programming language called Scala. Similarly, there is a programming language recently I delivered a training called Clojure. All these things, there is a Kotlin compiler, and there is a Scala compiler, and there is a Clojure compiler. What these compilers does, these compilers, they compile to Java bytecode. So what happened from here? Everything is same. To run Java, to run Scala, to run Clojure, the ultimate target is Java bytecode, and then JVM will take care of that. But Go, I think there is no other programming language that are targeted to plan and assembly code. Just telling you, if you want to create your own programming language, you can do like that. So they can interoperate actually. This is the Java compilation process. All these are compilers, but ultimately they are all converted to Java bytecode, and then they can run using JVM. Different programming languages, but all of them are converted to intermediate language or intermediate representation, which we call it as a Java bytecode. So this is what actually what Go is: compiled general purpose programming language. It's also called a systems programming language, fast compilation, uh, very good performance, easy to learn. There is a garbage collector. You don't need to install a separate runtime. It gives static binaries. It's designed for cloud native computing, application cross compilation and builds. Go concurrency. Concurrency is the first class citizen. It has got its own exception handling. It's not object oriented. It's not a procedural, but it can be called as a hybrid. It has got a static linking, which is really wonderful thing. And then this is the compilation process of Go source code. You write source code, you run Go compiler, It is converted to plan and assembly code. From here, this is a tool chain actually. All these tools are already there whenever you install Go in a machine. This is a tool chain. Plan and assembly code Go compiler converts on a successful compilation. From here, there is an assembler. It converts to some machine code. And there is a linker which links everything and bundle together and create a binary file. Okay, this is just a hypothetical programming language. There is no programming language, something called JP. I'm just telling you. For example, you want to write the same JP as a Java backend. Okay, then you write your own programming language, something called JP. You have a compiler and then you convert everything to JVM. For example, you are targeting JVM or Plan 9 assembly, you convert to Plan 9. Similarly, for Rust, C++, and all, there is something called LLVM here. Here, LLVM front end and then LLVM backend comes into the picture. This is the full tool chain actually until the binary or a package is created. This is what actually the basic of what Go language is, why Go is preferred nowadays because of smaller binaries, no dependencies. It's better fit for cloud native development. Concurrency has got a lot of support for concurrency, cross compilation. It's not very heavy object oriented, but still whatever you can do in object oriented, you can do in Go and then static linking. This is what actually what uh, the Go programming language is. Any questions you have? Otherwise, we can close the session and tomorrow we'll start working with some examples.
No, yes.
Hmm? Yeah.